All right, so 10.6. So this section is on determinants and Kramer's rule. So the first half we're going to talk about determinants and maybe the first two-thirds, I don't know. But a determinant is just kind of a numerical way that we can represent a matrix. And obviously, one number, two matrices could have the same determinant. So it's not a unique way to represent a matrix, but it is a way that we can kind of measure a matrix. So a determinant, the way we calculate for a 2 by 2 matrix is this formula AD minus BC. And it should look familiar because in the last section when we found the inverse of a 2 by 2, we were part of the calculation was 1 over AD minus BC. And so it's just 1 over the determinant of the 2 by 2 matrix. So very simple calculations. Let's look at this first example of a 2 by 2 for A. So let me get my pen here. So the determinant of A, and instead of writing determinant of A, most of the time we write it with looks like absolute value, but in the context that this is a determinant. So it's just going to be 6 times 3 minus -3 times 2. So that would be 18 plus 6. So that would be 24. And what we found in the last section is this matrix would have an inverse because as long as the determinant is non-zero, the matrix has an inverse. And we didn't actually say that in the last one, but we can kind of infer that because if we were dividing by that number, so if that number is 0, there's no inverse. So we can also say that if the determinant is 0, then there's no inverse. And so that applies also to higher or bigger matrices, n by n, whatever size. Now, once we get to larger matrices, we need to talk about what's called minors and cofactors. So a minor is the determinant of the matrix. So if we take any element in the matrix, A sub ij, whatever, the second row, third column, or third row, third column, whatever it is, whatever entry you want, pick an entry. If you delete the row and column, so let's just say we have, here's a 3 by 3 matrix, and let's pick that entry right there. And so the minor, to find the minor, we would delete that column with that entry, and we would delete that row of that entry. And so that leaves these 4 entries in a 2 by 2 matrix. And so if we write these as a 2 by 2 matrix, we can find that determinant, and that would be the minor for that entry. And then the cofactor for that entry is just -1, and then we add whatever row plus column we're in as an exponent. And so this is either going to be -1 or 1, depending on where you're at. And then times whatever the minor entry is, and that gives us the cofactor. So in this case, this would be the third row, the second column. So this would be a negative entry because 3 plus 2 is 5, so -1 to the 5th is a -1, and then times whatever that determinant is. So let's look at an example. We can find the minor for the first row, second column. So first row, second column, that would be that. We're going to delete the first row. We're going to delete the second column. And so the minor of 1, 2 would be the determinant of 0, 4, -2, 6. And so finding the determinant 0 times 6 minus 4 times -2, that would just give us +8. And then if we want to find the cofactor, that would be a -1 times 1 plus 2 for the 1 and the 2 here, times the minor, which would be 8. So -1 to the third, which would be -1, and then times 8, so that'd be a -8. And so that's all you got to do. We're just whatever row and column we're on, delete that, and then whatever's left, find the determinant for that. So let's try again with the third row, third column. And so we'll delete the third row, third column. And so then we're just left with this 2 by 2 matrix there. So M3, we're finding the determinant for 2, 3, 0, 2. Whoops. 2, 3, 0, 2. And so that'd be 2 times 2 minus 3 times 0, which gives us 4. And then for the cofactor, A33, that would be -1 to the 3 plus 3 times the minor, which would be 4. And then so we have -1 to the 6th, which gives +1 times 4. So this would just be 4. Okay, so this is kind of how we find determinants of bigger matrices. You're really just finding 2 by 2 determinants over and over again. And then add them together in some way, which we're going to see here in a second. So the determinant of any square matrix is essentially finding, and you can pick any row or you can pick any column. So typically you just pick the first row, although it could be more convenient to pick another row, which we'll see. But let's say we pick the first row, then for A11, you would find the cofactor, which would be this lower matrix here. And then A12, and then you find its cofactor, A13, find its cofactor, all the way up to A11 or A1n and find its cofactor. And then you add them all together, and that gives you the determinant. So, so it is a little bit lengthy if it's a big matrix, but we'll do a 3 by 3 here. So, and we'll do this two ways. I'll show. So we'll do this just the regular, the kind of the way it showed it in the last page, and then we'll do it the easier way after this. So we're going to take the numbers along the first row, and then we're going to multiply this by the determinant of, we're deleting this first column, we're deleting the first row, finding the determinant of this. And then what happens when we go to this one, we're going to subtract the 3. And the reason for that, this is the first row. Well, let's go back to this one. This is the first row in the first column. So that would be A11. So we multiply this by -1 to the 1 plus 1. And in fact, let's delete this, and we'll kind of walk through this a little bit slower. +3 times -1. This is the first row, second column, so that'd be to the 1 plus 2 times the determinant, delete the first row in the second column. So we have 0, 4, -2, 6. And then -1 here, and then times the -1. This is the first row, third column. And then times the determinant of the off entries, I guess we could say. So 0, 2, -2, 5. All right. I didn't write it here, but that'd be -1 to the 1 plus 1, which is just 1. So we don't need to write it. All right. So 2. Now let's find this determinant. 2 times 6 minus 4 times 5. And then we have, this would be a -1. So let's just make that a -3. And then times 0 times 6 minus 4 times -2. -1 to the 4th would be a +1. So then the -1 there. So minus 0 times 5 minus 2 times -2. So we have 12 minus 20, that'd be -8. Minus 3, 0 plus 8, so that'd be an 8. And then minus 4. So that gives us -16 minus 24 minus 4. So that gives us a -44 for that determinant. Okay. Um, so now there is an easier, slightly, maybe not easier, but there's a quicker way to do it. So the quicker way to do it is to pick the row with the most zeros. So if we pick this row with a zero, or you can pick this column with a zero, um, that'd be a 0 times -1. And that's the second row, first column, although it doesn't matter because we're multiplying this by 0. Now delete the second row, first column. So we have 3, -1, 5, 6. And then plus 2 times -1. That's the second row, second column. And that would be 2, -1, -2, 6. And now I go to the 4, -1, second row, third column, and then the determinant of the 2, 3, -2, 5. And so now we don't have to worry about that one. That one is multiplied by 0, so we don't need it. -1 to the fourth would be a 1, so that'd be 2. And then let's go ahead and write that out. So 2 times 6 minus -1 times -2. And then -1 to the fifth, so that'd be -1. So we'll do a -4 there. And then 2 times 5 minus 3 times -2. So we have 2 times 12 minus 2, so that'd be a 10. And then minus 4, that'd be a 10 plus 6, so that'd be a 16. And we have 20 minus 64, which is a -44. So either way works. But if you pick the row or column with the most zeros, then it at least makes things quicker. It's not, I don't guess it's easier, but it is quicker that way. Okay, so that's calculating determinants. We'll move on to something else on the next video.